MANA, the International Center for Materials Nanoarchitectonics, is one of the best nanotechnology institutes in the world. MANA is situated on campus at NIMS, the National Institute for Materials Science in Tsukuba, known as Japan's Science City. Various innovative technologies related to energy, the environment, information, communication, and medicine must be further developed for a sustainable world. For such developments, new materials play an essential role. At the MANA Center, we are creating such innovative new materials based on a new concept known as Nanoarchitectonics.
What is Nanoarchitectonics used in the name of our center, MANA? Nanoarchitectonics is a new paradigm of nanotechnology to create innovative new materials by constructing or controlling or arranging nanometer scale structures which are very small. Most important aspect of nanoarchitectonics is to recognize that the control of nanometer scale structure is more or less ambiguous or unreliable in principle. Nevertheless, we have to create reliable materials for practical use. Nanoarchitectonics is prescription for that purpose.
MANA has been launched as one of the research centers of the World Premier Research Center Initiative in 2007. The WPI program is led by the Japanese government, and its aim is to build a globally accessible research center in Japan. Many brilliant researchers from all over the world have joined MANA, resulting in many great achievements.
We are very much interested in synthesis and application in functional materials. They include 1D nanotube, 2D nanoseed, and supermolecule. Recently, we have successfully synthesized functional nanoseed with various physical property. Now we are very much interested in electronic devices based on 2D oxide nanoseed. We use the 2D oxide nanoseed as a building block in Lego-like game. Then we successfully fabricated various device architecture like a capacitor and memory. They can be utilized for future electronics.
Our artificial brain project uses nanoarchitectonics for its assembly. Unlike normal methods where we, for instance, carve away material and engineer it into a particular form, what we do using nanoarchitectonics is to assemble complex three-dimensional wiring structures. And these structures are directed to grow in a particular way to form synaptic connections. This results in some billion synaptic connections, which is impossible to do using conventional semiconductor technologies and related techniques.
Nano Power field is developing materials for an energy sustainable society. The electron transfer property is the most important fact for high performance energy devices like secondary battery, fuel battery, and solar panel. We believe that nanoarchitectonics can make it possible. Recently, we have succeeded in developing new fusible light sensitive photocatalytic materials for artificial photosynthesis. This research achievement could be a promising approach against global warming.
Nanolife field is focusing on the topics related to our life. The target of my research is to create a new type of sensor, especially a smell sensor, that can contribute to supporting our healthy life in easier ways. Nanoarchitectonics is a key to integrate all related technologies in a reasonable way.
More than half of the researchers at MANA are from abroad. The WPI MANA building has lots of communication spaces for researchers to freely discuss across cultural and research field boundaries.
I put this panel here and there in the building of this center, MANA. This panel says the fruits of your research are proportional to the number of your conversations with others. This is true, without doubt.
MANA appoints young researchers who have produced outstanding research achievement as MANA independent scientists. the independent scientists are granted the independent authority over their research. MANA provides them with opportunity to spend their own stay overseas, as well as supporting them with interdisciplinary research, and providing them with world-class researchers as their mentors.
To support foreign researchers, I believe all the staff in our administration office and in technical support team must be a family of them.
When we say International Research Center, it means the place that every little job here should be done all in English, like assisting in getting visas, arranging business trips, and purchasing lab equipment. We also hope that people feel familiar with Japan, so we organize Japanese language classes and Japanese culture classes.
Scientific research is essentially an international affair. It's not really something that one country does by themselves, and each country has its own advantages. MANA, for instance, in Japan, has the most marvelous laboratories, state-of-the-art equipment, and Japanese scientists that have a particular way of thinking. In California, the California Nanosystems Institute at UCLA is one of the most leading nano research institutes in the country. And by combining both the strengths of all the technologies we have, together with the creative process, the international process of doing research, we can achieve far more than we could do by just working alone.
After MANA was launched in 2007, we've targeted to become the best research center in the world in the field of novel new materials development. And we believe in these 7 years we have come close to this target. Namely, our center MANA has become an international hub in the field of material science and technology. And our challenge on the basis of nanoarchitectonics concept will continue more and more. So we hope many young scientists in the world will join us.